Okay, welcome back, Algebra Express. We are on Rockswold 3.5b. We are finishing up the Rockswold 3.5 chapter over transformations. And so we're doing non-rigid transformations, an intro to solving graphically. So in this section, what we're going to talk about mostly is vertical stretching and shrinking. So if I'm looking on at this first graph, 0.1, 1, 2, 4 might be a good point. Looks sort of reflective. So now if I look at y equals 2x squared, I want to think about this. And you may not have to think about this too much because I think we're only doing vertical stretching and shrinking. But you might notice that the 2 is on the outside of the x squared. So the 2 is not being squared with the x. It is sort of like it's outside the function. So if this is outside the function, and you can think about like plugging points into this, you can do a little t-chart, but essentially what you're going to do is you're going to plug something into x squared, and then you're going to multiply it by 2. So I'm taking, another way is to take the y quantities here and multiply these by 2. So 0 is going to stay 0. 1, 2, and 8. So if I look at that 1, 2, 0. And it's reflective just like the other thing, right? We have a negative 1, 2. So how are they describing this graph? So if we were to draw our original graph on here, it would look. So how do we go from one to the other? So the best sort of way I can describe this is describe this as look, think of this as like a sheet of rubber, and you take the sheet of rubber and maybe like silly putty or something, and you're just like stretching it this way. So we're stretching this thing up and down. We stretch it up and down, which end up with our final sort of product there. So that one is a stretch. And I'm going to half my x squared. So half 1 comma 1 half will be a point. 2 comma 2 will be a point now. So I'm taking these values and I'm having them. And if we look 0, 0's on there, 1 comma half is like right there. That's about there. Comma 2 is another point. And so it's like I took this thing, and this one was a stretch. This one is. So it's like I kind of squished it. Like I put these one in one of those heavy compressors, right? And just kind of squish it down. And so that's a stretch, that's a shrink. They leave something off here. Okay. So they say y equals c f of x. So if we throw something in front of our function that's being multiplied, if we're multiplying by something greater than 1, any number greater than 1 is going to give you a larger number. So this is going to stretch it if we multiply by something that is larger than 1, right? If I multiply even like 1 point, it's going to get a little bit larger. Not a lot larger, but it will still get larger. So even if I go slightly over 1, if I multiply by 1, they don't tell you what that is, but that's just your original function back at you, right? So if I multiply by 1, it's not doing anything to it. So they don't even mention that. You just have your original function. They c is less than 1. And what they really mean is a positive number less than 1 because the negatives are going to flip it. Remember, we did that last time. The negatives are going to flip it about something. So what they really mean is that you have some number between 0 and 1, so you have some sort of fraction. So take any sort of fraction out there. We have a half up there. If we 3/4 something, right? If we do a number less than 1, it is some sort of fraction that we're multiplying by. So it is going to end up getting smaller. So this is going to shrink it vertically by a factor of c is what we also say. So a little bit with the vocabulary here. We can say this is stretched by a factor of 2. This is shrunk by a factor of 1/2. Graph the following based on the graph of f. So we want to take this graph. And we already kind of know, you should know from the previous problem, this looks like our stretch, this looks like our shrink. So this is basically the same problem with a different graph that they give you. So they start you off with this graph. So the best thing to do is to off your points, -0, -1. And my third point is so we have our 3 points. So I did this earlier, but if I'm stretching something, this is like I'm taking 2 and multiplying it by something. I'm multiplying it by my f of x, which is sort of like my y quantity. So if I take -3, 0, I multiply 0 by 2, I'm going to still get 0. And I take a -1, 2. I want to multiply 2 by 2 is going to give me -1, 4. And my last point here, it looks like 3, -2. This is multiplying this by 2. It's going to give me a point. And so now I need to graph my points. So I go 1, 2, 3. 2. Line graph we need to collect. There we go. That's enough. I probably should have got my ruler for that one to keep it straight, but try and do it quickly. Does that look like what you thought it was going to do? What did we say this was going to do? Stretch this thing by a factor of 2? Was it like I took this thing and stretched it? So things on the axis, you might notice when you stretch things, things on the axis stay on the axis. But things above the axis are going to get stretched up. Things below the axis will get stretched down. All right, and now we're looking at this thing. Yeah, this is the first one. I have stuff above and below the axis, so I guess it's something to look at, right? Well, what about this one? So you can probably think before you do it, it should be a shrink. These points. We're not doing anything with that number. But now I'm coming along. I look at 0. I want to multiply 0 by a half. So I want a half of 0. It's still going to be 0. I take the -1, 2. I want to half the 2. I come along here to my 3. It says 3, -2. I want to half a -2. Now these are the 3 points. I want to plot -3. That one's not changing again. One is and so does this look like what we thought? We were starting with this thing, and we said we were going to do a vertical shrink. And so hopefully that looks like what you were thinking. We're taking this thing and we're going squishing it down, right? Okay. And I know to note this thing, things on the axis stay on the axis. Things above the axis are going to come in closer to the axis, right? So things above the axis are going to go down closer to the axis. Things below the axis will come up closer to the axis. So everything should be getting closer to the axis. Everything should be getting further away from the axis. It's like this is our center, and we're just stretching it, all right? It's like it's a rubber pad or something. Put it on some silly putty. Stretch it away. Okay, so 1/4, the absolute value of x. So there's a few ways to do this. I know I have to quarter things. So if you wanted to do a t-chart, that might be a good way to get at this. That is one sort of way. If you want to do it, you can do it. This is my y. The graph that you have in if I want to draw the original y equals absolute value. So if I want to draw the absolute value graph, it should look something like that. So what is this quarter going to do before we even draw this other graph? You should know what this thing is doing. So we're looking at 1/4. This should be by a factor of 1/4. So I know I'm going to quarter things. So I think if I go big points. So I'm going to do -4. I'm going to plug in -4 to the absolute value. It's going to give me a +4. Then I'm going to quarter it. That's going to give me. It's going to give me 1. So if you wanted to graph these things on the origin, points on the origin are not going to move. Hopefully you can see. Sort of like the other one shrunk. So we might want to pick a few more points. 8 would be the next thing that would be easy to do. And if we plug in 8. I'm a straight ruler. So does this look like what we think? Did we take that original graph that's drawn in pencil and then squish it down in some sort of compressed looking thing? That's kind of what it looks like. Okay. Another way we can do this is we can just look at the y values too, right? I think that that's kind of the way I was doing it in my head, probably a little bit. So we're looking at what, 4? We're going to divide by 4. And I knew that was where it's going to be 1. Okay, so this is y equals 3 the square root of x. So you do have to know sort of like what these graphs look like. Okay, so I have these points. And I want to go to 3x the table, or you can do it here. So if I'm going 0, 0, 0, 0, so now if I'm coming up 1, I don't want to come up 1. I want to come up 3 times that. So I'm coming up 1, 2, 3. I'm coming up 2 here, so I want to come up 1, 2, 3, 4, 5, 6. So this is one way you can do it. I'm about to do it another way, so don't freak out if you don't understand this. 1, 2, 3 spots up here. So I got to go up 3 times that, which would be 9. So if you can do it sort of straight off this graph and understand that you're doing 3 times the y quantity, that's one sort of way you can do it. If not, you might notice I'm not changing the x values that I'm picking up. But now I'm doing 3 times this. And so these are the points that I'm plotting: 0, 0, 1, 3, 4, 6, and 9. 9 should be the new points. And now I'm asking myself, is this what my graph should look like? Is this what I determined? So this should have been a stretch. 3 is greater than 1. That thing should definitely stretch it. Okay. So they give you this table, a summary of the transformations that we have learned. So these are all the transformations we learned starting from the vertical shift. So if you add, you're going up. If you subtract, you're going down. The horizontal shift. So these were the things that were sort of like the opposite of what you would think they would be. So if we subtract, it's actually going to go right. If we add, it's going to go left. The reflections. So if we reflect our f of x or our y quantities, we're flipping the y quantities. So the flip and the y's go up and down. So we're going to flip about the x. This, we're flipping our x quantities. So we're putting a negative on our x. This is going to flip about the y-axis. This guy. So if we have something greater than 1, something larger than just a fractional amount, it is going to make that thing larger when we multiply it. If it is just a fractional amount, it is going to make that thing smaller and it's going to shrink it. So this is the new thing that we learned today. Excuse me. These 3 previous properties, or these 3 previous sections, and their properties were from the last lecture. Okay, so now we're looking at this. This is 2 times the absolute value of x minus 5. So there are a few ways you can do this. You can set up a table if you want. Or you can graph the absolute value function. Another way is we can go to absolute value function. Let's do it that way. I want to take some points off of this graph, maybe define this graph. And you can do it with the table if you want, but I'm going to do it like probably this way, just to give you all some options with how you sort of solve these things. So 0, 0 is another point. Here to 5. 5, 5 is another 2. And if I look at this thing, this tells me 2 times the absolute value of x minus 5. I just want to do it point by point with these 3 points. It should give me a pretty good idea what my other graph is going to look like. But I do 2 to the absolute value of x minus 5. So I am doing this operation, but I'm really only doing this operation to this thing. So I do 2 times 0, 2 times the absolute value of 0 is 0. And I have to subtract 5. So this should be 5. If I do 2 times the absolute value of 5 is 5, 2 times 5 is 10, then I subtract 5, I should be getting 5. And if I plug in a minus 5, 2 times the absolute value of a minus 5 is 2 times 5. That is 10, and then I subtract 5, is going to give me 5. I'm just plugging it into my function to get my y quantity. And if you do a t-chart, you should totally get the same numbers out of that thing. It's just this might be a little faster in some scenarios, right? I'm just trying to give you a few different tools and ways to work this thing out. But I have 0 minus 5 is the first point. So I think I need to draw this. Let's draw this one in red. 0 minus 1, 2, 3, 4, 5. 0 minus 5, I got to go 5, comma 5, 5, comma 5, go minus 5, comma 5. Ooh, that's not changing the point at all, is it? Just recognize that. Okay. Okay, so it might be beneficial to grab like 2 more points just to look at this thing beyond what 5, because it looks like they're going through each other at 5 maybe. So let's go 7, 7, 7, and what? Minus 7, 7 are points on my graph. So if I do 2 times 7 gives me 14, minus 5 gives me 9. So I think 7 and 9 should also be points. 5, 6, 7 should be 9. Red. If I do negative 7, it should be going to add 9. So now trying to draw this thing. And before you drew it, hopefully you looked at the transformations that were sort of happening. But this thing is a stretch by a factor 2. This minus 5 is going to shift it down 5 units. So hopefully that's what this sort of looks like. We took this thing, we stretched it so it was taller, and we moved it down 5 units. So if you want to pick points off your graph, you can do that, and then you can adjust the y or adjust the x accordingly. Or you can do the sort of t-chart thing. It should give you the same solution. Okay, so this is the last problem we're going to do today. we have this problem, y equals f of x. So they give us this dot plot, or it's a line graph, I guess, because you got lines between them. They give us this line graph. And the thing that's defining this line graph, we've done these already, but the thing that's defining this line graph is these 3 points, the -3, 0, the -1, 2. Oh, is this the same one? I think it was the same one they gave us earlier. And 3, -2. I believe it's the same one they gave us earlier, but now we're doing multiple adjustments at one time. Okay. So if we're thinking about this, we want to know what these graph transformations are going to do. This is going to stretch it by a factor of 2. This is going to move it to the, think about this one, it's a -1, so that moves it to the right one. You're going to do what you say. All right, it might help secure some points. It might show that you know what you're doing a little bit, right? So that's a stretch, that's a right one unit. So if you wanted to, you can take this thing, you can move it right, you can move it each point right 1 unit, and then you could probably say this is going up 2, I got to go up 4 now. You could probably absolutely do that, but I want to take this point by point. If I start with -3, 0, now I look at this -3. So if I'm moving this thing right 1, and this is the thing that you really kind of got to think about. I know it says -1, but we're really going to add 1 to it. In 0, we want to stretch 0 by a factor of 2 now. So 0 times 2 is still going to give me 0. And I know I said it without maybe doing it, but think about going from this point to this point. This is how you move it right 1, by adding. You got to do the opposite of what it is in here. So we have to add 1 to get back to it. So this is -1, 2. So now I want you to try this. You should be trying these on your own before I do them. But if I take a -1, if I want to move it right 1 is the first thing I have to do. This is going to go to 0, -1 plus 1. And this 2 I have to stretch by a factor of 2. So 2 times 2 is going to give me 4. And then the last thing that I have over here is 3. 3 I want to move right 1, so I have to add 1 to it. It's going to become 4. -2, I want to stretch it by a factor of 2. It's going to become a -4. So now I'm plotting my points. So I got the -2, 0 on there. I want 0, 1, 2, 3, 4 right here, and 1, 2, 3, 4, 1, 2, 3, 4, -4 right there. Now I'm going to connect this thing. And so last time, I think we just took this thing and stretched it by a factor of 2. So hopefully it looks like that thing you stretched by a factor of 2, but moved right 1. So hopefully you notice both of these transformations in here. Ooh. Oh man, what's going to happen here? We get a -2f of x. That's going to do a thing, and that's going to do it. Stretch like we had previously, but that negative now, but you got to kind of tell me what it's going to flip or what it's going to reflect about. So that's going to be a flip about, I'm doing this to my y quantity, so it should be about the x-axis. So if we want to do this point by point, our x values are not changing, so I don't see anything happening to my x inside of my function. So these things should remain the same. -3, -1, and 3 are my x values. Now my y values, 0. I got to take that 0 and I have to multiply it by a -2. That one is going to stay there. -1, 2. I got to take that 2. I got to multiply it by a -2. This is going to become 4. I have to take this -2, multiply it by a -2, and it's going to become +4. So -3, comma 0, -1, comma -1, 2, 4, and 3, comma 1, 2, 3, 4. And we're connecting them. Do we see? Did it happen the way that we thought it was going to happen? Did it flip? It definitely did a flip about the x-axis, and then it did a stretch. So there is a flip and a stretch there. And so I know there's probably 2 more papers in your notes, but those are all about inequalities, and we are not doing inequalities anymore. So that should complete the lesson for today. I will see you all soon in class. Practice these things. Go play on Desmos for a minute, animate those variables. Have some fun with this lesson, but like also hopefully start understanding what's happening here, right? We'll say like this is one of the ones that, from my experience, students really struggle with, and they have to you have to play with these graphs a little bit to start seeing what's happening sometimes. But you got to practice math in order to get better at it, right? So it's not going to be perfect, and there's going to be a lot of mistakes probably starting out, but continue at it, continue studying, and I will see y'all soon.